Alright, hello year 11. I'm going to go through a quick example about bearings for some of you. If I seem like I'm in a bit of a bad mood, because I recorded this video without any sound and I have to do it again. So, yeah. Alright, so some people were asking me questions about bearings, saying that it's a little bit confusing. So I thought to best prepare you for your SAC, I'm going to spend a little bit of time doing a bearing question. Sorry if it's a little hard to read. I'll just get a bit closer just for this bit. So we're doing this top question, question 2. So one group of bushwalkers left a road running north-south to walk along a bearing of 60 degrees. The second group of walkers left the road 3 kilometers further north. They walked on a bearing of 110 degrees. Two groups met at point C where their paths intersected. Then we're going to first find the angle where the paths met. We're going to find the distance that each group walked, and we're going to find the bearing to come back, which is the question that I actually was asked, but I figured I'd just do this whole thing. Alright, so let me fix this up again. Alright, so we have a road. This is my road. Alright, isn't it beautiful? That could be the dividing line. Alright, so we have a road that they're walking down, and they first leave on a path of 60 degrees. So 60 degrees in there. And then it says 3 kilometers up the road, so I'm going to say that this distance here is 3 kilometers. They leave at an angle of 110, which is just a bit more than 90. So we're going to say they come like that. And they meet at point C. This is point A, and this is point B. Alright? And we know, sorry, I shouldn't have drawn it there. This angle in here, if the bearing they're going on is 110 degrees, this angle in here is 110 degrees. Now, we want to try and first find what's the angle C. So, if we have a straight line, the angle of that straight line is always 180, and we have 110 taking up this part of the angle, and then we've got this second part of the angle to make up 180. So, in order to get that, I'm going to minus 110 away from 180. So 180 minus 110 equals 70. So my angle in here is 70 degrees. Alright, then, because I know that all three angles inside a triangle add up to 180, I'm then going to minus the two interior angles that I have, so 70 minus 60 to give me this third angle, which is 50. Alright? Okay, so that's step 1. Then after that it tells me to find the distance that each group has walked. So in order to do that, I've got to find this side and this side. Now, logically speaking, because 3 kilometers is opposite 50 degrees, and 50 is the smallest angle, 3 kilometers should be the smallest side. So my angles here should be, 3.5, on my length should be 3.5 for opposite 60 and 4 opposite 70-ish, something like that. So I guess that's something to keep in mind. If we're getting the wrong answer there, it means we've done something wrong. So we'll do the smaller side first. So we'll do this side in here, and to do that we're going to use sine rule. So we're using 3 divided by sine 50 is equal to, what am I doing? A divided by sine 60. Alright? To get A on its own, I'm multiplying sine 60 to both sides. Sine 60. And I'm going to get 3 over sine 50 times sine 60. Alright? And that equals A. Now, like I said, I have actually done the working out for this already. So if I bring up my CAS, that value was 3.39. Alright? So I put that into my CAS, and I got A equals 3.39, which fits in with what I said. It's a bit bigger than this side. Now we'll get the third side, and it should be slightly bigger again. So if that's going up by 4s, it should be 3.8-ish. So now we'll figure out this longer side here, opposite 70. So we have 3 over sine 50 equals B, not 6, over sine 70. And I'm multiplying that across to get rid of it. Sine 70, and I get 3 over sine 50 times sine 70 equals B. Now, I'm going to go over to my CAD and see what that worked out to be. So I got 3.68, so that's about right. So our B equals 3.68, which makes sense because it's opposite the biggest angle, so it would be the biggest side. So there are our two sides. And now it says, if we want to go back on the second path, which is this one here, what would the bearing back be? And that may seem a little overwhelming at first, but I'm going to redraw it and remove a little bit of this information to make it easier. So I'm going to do this here. Right, so we have a straight line for our road. Then on a bearing of 110 degrees, we have a straight line over to a new position, and we want to know what's the bearing back. Alright, so we do know that this is 180 degrees, right? And then I could do an extra 90 degrees here. There's a reason that I'm not though, and that reason is because seeing as these are parallel lines, because they're both straight, and means that 110 degrees here is the same as the alternate angle, which is 100 degrees on this side. 110 degrees, sorry. So they're both exactly the same. So if I have 180 degrees already, plus 110 degrees, I'm going to get 290 degrees true. Or if I want to do it in compass form, I know that directly west is 270 degrees. So that means that this little gap in here is 20, and this distance here should be 70, which is actually the same as in our triangle from before, because it's the alternate angle to this one. So if that's 70, I know that I'm going north 70 degrees west. And they are our two, sorry I cut that little bit off, but they are our two bearings back to the original road. Hope that helped. Good luck with the SAC. If you have any more questions, come and see me beforehand. See ya.